Hello, so today we are going to see a new topic that is on picking. So we will be dealing some of the numerical aspects that are asked in the gate examination. So talking about the very first point, so some important terms of what actually happens in the picking process is uh, pick inserts the weft onto the warp yarn that is inserted on the warper's beam. Warping process. Warper's beam is created and now weft is inserted. Weft insertion takes place by the process of picking. The weft takes and the yarn is picked from the and inserted onto the weft. So this is the entire mechanism on which the weft insertion mechanism WIR weft insertion mechanism works. So we will see some of the basic aspects that are associated with all these things. Now, some important terms are loom speed. Let us consider this as N, and if reed width is represented as R in meters and this in RPM, and now the length of the shuttle, because shuttle takes shuttle inside the shuttle, the weft yarn is inserted and the shuttle takes place. The shuttle takes place from this to this and the weft is inserted and the shuttle moves back. So there are many mechanisms: rapier, jacquard, and dobby. So these are weft, how these things are inserted. In jacquard, individual yarn is inserted one by one. So length of shuttle is represented as L in meters and the angle that it makes is represented as theta. So the question that is asked in the gate examination: shuttle velocity. Shuttle velocity that is represented by V. So the formula of V is equal to 6N R plus L upon theta meter per second. So what we can deduce from this formula is V is directly proportional to N, V is directly proportional to R. Now we will also look on to other formulas. Kinetic energy of the shuttle, because when the shuttle is inserted, due to the high speed and velocity, kinetic energy is developed inside, because kinetic energy is developed when a body or a material is in motion and the potential energy is developed when it is in rest. So if I talk about, so here kinetic energy will be is equal to kinetic energy Ke is equal to 18 mn square r plus l का whole square ms mass. So upon theta square. Theta is the angle in degrees. So this is the kinetic energy, and due to these kinetic energy, one more formula, power. So power is equal to 3 upon 10 mn cube r plus l का whole square upon theta square into 10 की power into 10. So you can say that into 10. So this 10 to 10 will get cancelled. 3 mn cube r plus l का whole square upon theta square. What we can say that it is in watt. If you will multiply, then it will be 10 की power minus 4 kilowatt. This is the entire formula for power. So what you can reduce, that power is directly proportional to n cube power is inversely proportional to theta square, and power is directly proportional to r plus l whole square. So what exactly this, which type of questions are asked in the gate examination, we will see one by one. So the first question is, for a twofold increase in reed width, the picking power of the shuttle loom needs to be increased by, for a twofold increase in reed width is increased by two times, so the power will be increased by how much? So you know power is directly proportional to r square, r plus l ka whole square. So here only r is given, so we will take only r, so it will be 2 square. So power will also increase by 4 times, so 4 times power will increase. This is the gate I think 2 mark question of previous year. And now this is gate also gate repeated question. Here read width is given, I think it is asked in 2018 or so on. Read width is given to be 1.75 meter. I'm just telling you the example. And the shuttle is moving with a velocity of 180 rpm. So rpm is equal to 180, means n is equal to 180, and the shuttle that makes an angle of 120 degree at the starting and 240 degree at the end. So we will take in degrees. So theta 1 is given as 120 degree and theta 2 is given as 240 degree. So which angle we should use? So we will take the difference of the two, theta 2 minus theta 1. We will always take the difference, and the shuttle length is given to be 0.25 meter. Then the shuttle velocity in meter per second, meter per minute would be, they asked in meter per minute, I guess. Meter per minute or meter per second, the question can be asked in any of the form. So you know V is equal to 6n r plus l upon theta. So theta 2 minus theta 1, always in degrees. So 6n 180 into 0.25 plus 1.75, it is 2, upon theta 2 minus theta 1, it is 120 degree. If you will solve, so this 2 times this, 3 times this 18 meter per minute, rpm, rotation per minute, so meter per minute, 18 meter per minute is the answer. This is the question that was asked.